Hey there, and welcome to my second video in the series of Python for Maya artists. The first video was an intro course, and that was for newcomers to the Python language, and we went over things like objects and the syntax of Python, and learned to write functions and how to get them integrated into Maya and write some basic tools. And we also looked at the commands module for running Python commands in Maya. And in this video, we're going to take the approach, a more intermediate approach. We're going to assume that you've got a fundamental knowledge of Python to a certain degree, to a basic working degree. And we're going to get into a focus on class structures and inheritance, which I think are key concepts when you're writing larger, complete tools in Maya and you want to reuse code and redistribute code. And we're also going to look at the user interface, how to write some user interface code, and a little bit of the MayaPython plugin API, which is the lower level interface into Maya. So like I said, this video will start off with a general Python lesson, and then we'll get into more Maya specific things. And I would say that the beginning of this video is beginner to intermediate, and then most of the video is intermediate level, and then we finish out starting to borderline on an advanced topic when we get into the API. I also wanted to explain that whereas you might see these examples being focused on maybe more pipeline and general topics, my background is a lot of pipeline development, and you may be an animator or do rigging or do shaders, lighting, whatever it is. And while I can't cover every single example for every facet of 3D, you can take all these concepts and use them to write things that are specific to your needs. Alright, so let's get started looking at class structure and inheritance. Okay, so let's start by asking, what is a class? A class is a structure that's similar in how it looks to a function, but encompasses functions and attributes and definitions that make up a common description of something. Whereas if you had these objects like this, and this is a sphere and a cube, but they both are geometry. And in Maya, they have translation, rotation, scale, visibility. Both of them have this functionality. And then beyond that, they split off into their specific functionality. A sphere has a radius, whereas a cube doesn't. It just works in terms of height and width and depth. So you can define common functionality in a central abstract area like geometry, and then split off and just inherit everything that you defined up here and add on things that are different, or override things from the original one that are now a different way of doing it. So a class lets us put this code together and reuse it and write things that we can keep building off of, and it helps us keep our code very organized. And let's, in order to illustrate that, I'm going to pop open the script editor, bring this up a bit, and clear this out here, and I'm going to be working in terms of pasting code. I typed a lot more in the first video, but there's a lot more code in this video, so I'm going to paste in blocks of it and we'll go through it line by line and figure it out. In the project directory that comes with this video, I have all the code, even in stages that we're working on. We're going to look at sphere, and I've got two stages of it where we start simple and then we add on some more. So we're going to look at sphere 1, so you can open that if you want to follow along, and I'm going to paste in. Okay, this is a basic start of a class. We're calling our class sphere, and just like we would define a function, the way we start a class is saying the keyword class, the name of our class, and then in parentheses you would put in anything that you want to inherit from a parent superclass. A superclass is a class above our current class that we inherit from, and a subclass would be the class that's doing the inheriting. This is the old way of saying to start a new class, but the new way in Python is to always inherit from the lowest level object, which is object, and we put it in parentheses. So if we're starting a brand new class, not inheriting from anything, we at least want to inherit from object to get some of the new class functionality. And then everything we define is in the class block. Now, the first important thing that you'd want to know about in a class is a special function called init. And you can know it's special because it has double underscores surrounding it, meaning it's a built-in that we're going to overload. An overload meaning that object came with an init, and we are going to define our own init. And what we say is when any new sphere gets created, it will always automatically run this init function for us and set up our new copy of a sphere. And we can put in the attributes right here. So we want to say our sphere has a default name value called sphere and a default color value that's just an empty string. And what you'll notice is this keyword self, which is new to the concept of classes coming from functions. You didn't see this first attribute called self. But in a class, when you have, because you're defining a template, whenever you have copies of your sphere, you never know what that object is going to be by the end user. But you know that inside your functions, we can say it's called self. So every copy at that moment is called self. And every function in here should start with self in these methods. So what we do is when we bring in name, we need to save it. So we're going to say self.color equals the color attribute, and self.name equals the name attribute that was passed in. Now it's saved. And if we were to run this, and I'm going to have two tabs open, one where I keep this code, and then I'll switch over here, and I can say s equals sphere. And if I print s, you'll see that you get a sphere object. That's different than if I just ran the sphere class. It's telling you that you're looking at a class sphere, but when I made a new instance of it, it says now it's a sphere object at this point in memory. So we've got this, and if I do a dir, if I do a dir on this, you'll see that it comes along with these built-in attributes that come with the class, and at the end is our two properties that we defined. So I can say s.color, and that was a default nothing, but s.name is sphere. And I can change that by saying new name, and I can also change the color by saying color equals red. And now if I print this, you'll see that we set it to red. So this is how you can create objects that carry their own properties, and you can pass these around. You can have 1,000 of these in a list with different names, different colors, and you can loop over them and just check the name of each one, the color of each one. And you can set this up for any kind of object you're creating that you want to add your own properties to. So that's the init, and then you would have more functions to do specific things with a sphere. So I'm going to go into our sphere 2, which adds a little more functionality, and I'm going to paste this in. Now, this is just tacking on some more functionality, and I'll explain what each of these things do. We've still got the init. I set the default color to red so that it always starts with a color. And you'll see up here that there is this definition of a tuple with some default colors in it, and it's outside all these functions. Now when you put something right here, this is called a class attribute, and it sets it up only once, whereas if you were to put it in here, if you were to put colors down on a line like this, self.colors, every time you create a copy it's going to redefine this. But we're going to say that these are the allowed colors that this sphere can be, and they're never going to change. So we're going to put it up here once as a master constant for all the objects. And what we did here is we added two setter methods to our sphere. The first one sets the color, the second one sets the name. And the reason you could create a setter as opposed to just the way we assigned it directly is now you have some control of how the color gets set. So we take the color and we make sure if the color is in self.colors, then set the color. Otherwise, do nothing. So it prevents them from saying an orange sphere or a yellow sphere. And when you create this colors, every instance has that reference to color. And when we come down here into set name, we make sure that they pass a name, and we also make sure that it casts the name into a string, so that even if they pass some other crazy value, we always make sure that the name is being set to a string. So let's set that in there. Let's create a new sphere, and let's look at what our color is. We didn't set a color, but it's red. We could have instantiated it with color equals blue. And now it's a blue sphere. Now, you can still do this method because there's nothing protecting you from it, but we've added this functionality, set color, which is the preferred way to set a color. And if I set the color orange, you'll notice that the color is still blue because it's not in s.colors. It needs to be in there. Now, if we change that and we added orange into this definition, then it would allow these colors to be set. So these setters give us a way to protect and do sort of setup before we set those values. We'll get into some more talks about the attributes versus the setters in some later examples. But the idea now is that when you had this sphere class and you had it in this file, like we said, sphere1, you can now reuse this code, this class. You can import this class, and you can build off of new shapes. And we're going to look at this. This is sort of a generic example of a class. It has nothing to do with Maya for the time being, but we're going to change this class up and see how we can make this a Maya sphere that sort of wraps around the commands Python module. So that'll be next. That's in Maya sphere. In the Maya sphere directory, we've got a couple files, and let's start with this Maya geom. And I'm going to bring up just an editor so we can take a look at a bigger view. But here's Maya geom, and it defines a class called Maya geom. We set an init with a default name called geometry, and we just make sure that the name variable gets set. And then we know that when we are defining a piece of Maya geometry, we can rename it, any piece of geometry, with the commands rename command. So we're just going to set a setName command that can set the name of the geometry and then update itself. And this is so that we can wrap the concept of a piece of geometry into a more Pythonic object that we can work with. And then we also define getTranslation, which we know that if we use commands transform command and pass it the name of the object, we can query the translation attributes. So we're going to wrap that up as a getTranslation. And again, we don't know what the object will be. We're just passing self because we know self will be that object at that moment. We also define a setTranslation method, which takes a default x, y, and z attribute, and we say if x is not none, then move it in x in the object space. If y is not none, move it in y. If z is not none, move it in z. So this sets up a framework for a Maya geometry object. And then what we're going to do, and you can't do much with that right now because it doesn't really represent any specific geometry. But if we create in Maya sphere 1, we first off import from the Maya geom module the class name Maya geom, because the module name is Maya geom, the class name is capital. We import it. Now we have this class. And you remember I said that in here is where, in this class definition, is where you define who you want to inherit from. So instead of object, we're going to inherit from Maya geom. That means that this Maya sphere is a subclass of Maya geom, and Maya geom is the superclass of Maya sphere. So we have an inheritance setting up. And whenever we inherit from another class, we want to make sure we define our init if we need it. But if we do define an init, we should always make sure to call the superclass init, because it might have its own special setup. And if you overload this method and you don't call this, you might lose out on some basic setup. In this case, it wouldn't hurt us because we're setting self.name here, and we also set self.name here. But if this had special other setup that we don't do, we want to make sure that we call it first, and we pass the reference self in to the init, because init requires at least a self attribute. And if it had other attributes, we could pass the name in down here as well. And then in addition to that, we're going to make a sphere. So anytime you create a new Maya sphere, we're going to make a sphere with these default attributes, and we're going to take the name and set it to self.name. So let's take a look at how that works. I'm going to hide this, and I'm going to go in here, and for a second let me talk about some quick setup. What we have over in this tab is something that makes it really easy to work in Maya when you're working with classes and you keep changing the code. What I have is this import sys, and then I add to the sys path the location of the Maya sphere code. So it puts it onto your Python path. Now normally you would actually edit, in the last video I talked about how to edit your Python path so you could have all your code in an area. You would just put your code in that area, but in this case I'm working with a kind of a foreign path. So you can also do this just for working with the project. Just add this path to your Python path. Now you have all the code in here available to you. And first thing we're going to do is import. Now you don't need to do this. I'm going to start with this right here. Import Maya sphere. Now we have Maya sphere. Let's jump over here, clear out our previous stuff, and let's say msphere equals Maya. Now if you remember, this is the class and the module, and inside the class is the Maya sphere. So we need to say Maya sphere 1 Maya sphere, and we're going to just do the defaults. Now watch what happens. Let me hide this here, and let's see here, move this over. Okay, I have my scroll set up very strange. I don't know why. Okay, if we create this sphere, it actually makes a sphere because we set up our code. Let's see here. Because we set up our code, anytime you init a new sphere, it's going to make the sphere, and it's going to save the name of that sphere. So if we do msphere name, you have the actual name of the sphere, which, if you look over here, is the actual name of the sphere. And we had msphere get translation, if I can even say it properly. Right? Now we can also do set translation. And set translation, if we look at our code again, you'll notice that in the Maya sphere we don't have any of that. So where is it coming from? It's being inherited from our Maya geometry class because we set up some basic functionality, and it just comes along when we inherit from it. So our set translation takes the optional XYZ values. So let's go back over to Maya, and let's say we want to move it in X. X equals 2. Notice the sphere moved. And you'll see up here in translate X it also moved. We can say 1. It moves it back. I can add the Y. Let's move it up 3 in Y. And you'll see what we did here is we wrapped up the concept of a sphere, which is normally just a string, because when we reference with the Python commands module, we know that any object is always just going to have the string path to that, but we wanted to wrap it up in something that's more Pythonic, so we don't have to keep calling commands.transform commands. It knows its name. We know we just want to set the translation or get the translation, and you can see when we get it, it's actually getting the translation based on the name, because under the hood it's running the functions that we wrapped up. Now let's expand the class even more. Let's open up Maya sphere 2. And in Maya sphere 2, what we have is a little bit more in the init. What we have is we passed in this thing called keyword args, and we set keyword args name equals name, object equals true, and we call that sphere. Now, why did we do this? What we did here, this could be called anything we want, but in Habit I just call it KWArgs, means keyword args, and it represents the idea of doing key equals value, key or value equals key, like that. Instead of having to explicitly say this is what our class takes, I can use this special Python symbol dot dot. That means expand this into keyword args. So whatever they pass in, name equals value, it comes in like a dictionary. As you can see, I treat it like a dictionary. I say make sure the name is equal to the name, make sure the object is set to true, and then when I call sphere with keyword args, which then expands into all the options, it ends up calling sphere with whatever arbitrary stuff we pass to it. So how does that work? Let's go over here. And this is why I was setting it up this way. I can say 2, right? And then I can go over here and let's delete this and set this to 2. Now, this is where we would use that idea of keyword args. We can say name equals sphere 2, and this in here is where we would pass any of our functions to the command sphere reference. And let's see, I can look this up here. Let's see, quick help. You'll see that all of these, I don't have to code all these into my class. I just have to accept any arbitrary keyword arg. So if I want to say specify the radius, let me create a new scene here. If I want to specify the radius equals 5, you'll notice that I don't have that radius function in my code, but I passed it on to create the sphere, and now the sphere radius is 5. So that's a way to pass along when you're wrapping up these functions with this KWArgs. The version of this called args, like this, would be everything that doesn't have a value as a list. This would come in as a list. So if I had gone over here and I said 1, 2, 3, not equals anything else, those would just come in a big list that I could use. But now we've got this sphere that's got the radius at 5. And let's look at our code again. And we always just, the reason we did it like this is because we wanted to make sure it was always running this flag as true. That's a way for me to make sure that this is always true. And then we just save the name as normal. So as you can see, we're still inheriting from geom. We just modified our init a little bit, and then we expanded this set translation. Now, the previous one didn't have set translation. The base class Maya Geom has this set, but this is somewhat, messy, inefficient. It's repetitive. So what I did was I said, well, I want to make this implementation of set translation better. So what I did was I just looped over all the attributes x, y, z, and I used this special locals command, and that tells you all the variables that are available in this scope inside set translation. So this locals would show you a dictionary, and it would have XYZ available to it. So I'm looping over XYZ like this, and then I'm pulling out the value of XYZ, and I say if it's not none, so if they passed X is not none, or Y is not none, or Z is not none, this will be true. And I create a basic dictionary of options where I say the name, which in this case could be X, so X could be true, or Y could be true, or Z could be true, and I make sure that object space is true and absolute is true. So these are our options for the move command. And then I just pass these options in using our special double star. And all this does is take a dictionary and expand it into keyword arguments. So this move command will get arbitrarily called depending on is it X or Y or Z. So I just overloaded this. Now, when you call set translation, it'll work the same. It just runs the code a different way. So if I were to be typing in here, and I made a change like this, and made some changes in my code, and I went over here. This is why I have these reload commands. This is how I kind of like to work sometimes. I made a change, so I had this. Now if I tried to use this, it would still be the same code because it's still in memory. So what I need to do is reload it, and you can tell it worked right because this will say PY. If I read it again, notice the PYC. Every time you it imports it, it makes this optimized version. So you can tell if it picked up your changes because the next time you ran it, it said PY. That's where the changes happen, but now it's still the same. So if I went over here and I made a new sphere, it would pick up the new changes. Let me clear this out here and get rid of this quick help. Okay, so I'm going to pull up the code again, and feel free to pause if you need to take a look at this code here. This is really not specifically necessary. There's nothing wrong with this, except it's good to try to not repeat your code, because the benefit of me having switched it to this more dynamic version is if I added another variable like weight or whatever the attribute was, I wouldn't have to go and copy paste that same block of code again, because this will just pick it up. It's going to loop over every locals that got defined, and if the name is not none, then it's going to add it to this list. So it was just a way to optimize and show you the concept of overloading, where it will pick up this newest version because of the way that the class resolves. It will first look at itself. So MySphere is first going to look at everything that's defined here. If it doesn't find it, it's going to go looking at MayaGeom for it. Alright, so let's open up the third version. And all we're doing is just adding more and more functionality. This is all the same. The set translation is the same, but then now we added get rotation, set rotation, which is very similar, except now it's calling commands rotate instead of commands move, and scale, which is calling transform and scale. They're very similar, but now we have three things we can apply. So if we go back over to Maya, go over here. I have a fast wheelie mouse that's set right now. I'll probably fix that in the next cut, but bear with me on that. So now we import our third sphere. And let's say our third sphere, we'll give it a name 3. That comes in, and you remember that we can actually now msphere, msphere set scale, and scale, looking at our code, has optional X, Y, and Z. So I can say let's just scale it on the X to Y 2.1, and let's